So our basic theoretical goal today, right, our primary goal is to try to think through how employers are going to choose wages and choose employment levels when rather than being able to hire as many workers as they want at some particular market wage, they are instead able to hire different numbers of employees, different numbers of workers, depending on the wage that they offer. Right? In other words, we're going to think about situations where instead of particular firms facing a labor supply curve like this, right, it's perfectly horizontal, we're going to have firms face a labor supply curve like this. Right, and I'm making this a little L to show that it's for a particular firm. Right, where a firm's going to be able to hire fewer workers when they offer lower wages, more workers when they offer higher wages, right, but they're not going to lose every single worker the minute that their wages drop below the market level. Okay, cool. So to do this, let's go back at first to understanding what we said would happen in the competitive case, right, in the case where we have a perfectly horizontal labor supply curve. In that case, what we did is we said that what firms are going to want to do is say, since I can hire as many workers as I want at wage W, I'm going to hire every worker that produces at least W's worth of stuff, right, W's worth of revenue for my firm, and no workers that produce less than W's worth of revenue for my firm. Right? So we said if we knew the marginal revenue product of a worker, which equals the price times the marginal product of labor, right? Which is, of course, just price times dF dL, right? Or if you prefer dQ dL, right? Output per worker. We're going to say that this is essentially going to tell us the dollars each worker produces, right? The dollars worth of revenue each worker brings. We're going to maximize our profits by hiring all the workers that produce more than W's worth of revenue and no workers that produce less than W's worth of revenue, right? So in a competitive market, we had this simple rule, right? Hire until marginal revenue equals marginal cost of a worker, right? Marginal revenue of a worker is going to be the price times the marginal product of labor, right? Marginal cost just equals the wage, right? Each worker costs us exactly W to hire, right? So our rule is going to be price times marginal product of labor equals W. This is going to be the firm labor demand. Right? Solving this for L is going to give us the firm labor. Right? This all looks familiar? So let's think about how this changes when instead of having a horizontal labor supply curve to a firm, I have an upward sloping labor supply curve to a firm. So if I have an upward sloping labor supply curve, something like this, right? Again, what this means is that I can hire fewer workers when I offer, let's say, $10 an hour than if I offered $12 an hour, and fewer workers if I offered $12 an hour than if I offered $15 an hour, right? But that there's never going to be a wage that, if I deviate below it, all of my workers quit immediately, right? In this case, I'm still going to have marginal revenue product, downward sloping just like before, right? So let's think about how many workers I ought to hire. And I'm going to give you a couple of options, and I want you to think about which you think is likely to happen. I'm going to call this option A, which is that I'm still going to hire at the intersection, right? Where the wage that I have to pay, actually let me rewrite this instead of labor supply. I'm going to write this as W of L, right? So the wage that I have to pay to get L workers, so that it's equivalent to marginal revenue product of L, right? Am I going to want to pay A, where wage equals marginal revenue product? Am I going to want to pay B, which is just something lower? Or do I want to pay C, which is something above? And I want you to think really for a moment about what you think is likely to happen. Okay. So many people, the most natural thing to think is that of course what I want to do is hire at A. For exactly the same reason that I wanted to hire at A when we had a competitive labor market, right? The last worker that I hired at A costs me in wages, right? Costs me a wage to hire that worker equal to what that worker produced. So hiring more workers would be foolish because I'd have to pay each of those workers more than they're producing in revenue. But paying fewer workers would also be foolish, right? Because then I would be able to hire an additional worker and pay them less than they were producing in revenue, right? So for the same reason as before, we might think that we should hire where wage equals marginal revenue product. The problem with this is that at A, that last worker that I hired produces exactly the same amount in revenue as they cost in wages, right? So the marginal profit from, I'll say worker A, is 0, right? Just in terms of their wage, their marginal revenue product minus wage equals 0 for that worker, right? Now that would be okay. That was true before, except that in order to get worker A to work for me, I have to raise my wages for everyone else, right? If I'm trying to choose the wage level for my firm, I have to raise the wages for all the workers that I'd already hired up to the level needed in order to attract worker A, right? So in order to get this person to work for me, I have to give all the workers I already had a raise. Giving all the workers I already had a raise costs me a lot of money, right? So I'm going to lose money on all the other workers in order to get to worker A, and I'm not going to make any money on worker A, right? Because I'm paying them exactly the same amount that they produce for me. So I'm never going to find it optimal to hire all the way to worker A. I'm always going to find it optimal, right? I'm going to lose money by giving raises to everyone else. So optimal is going to be to hire workers, right? Fewer workers than wage equals marginal revenue product, right? Once the wage equals the marginal revenue product, I know that I've hired too many people because I'm not making any money on the last person I hired. I'm losing money on everyone else by raising my wages enough to attract that worker. This makes sense? In other words, in monopsony, when I'm choosing what wages to pay, each worker really has 2 costs instead of 1 cost. Right? The first cost of hiring an extra worker is the normal cost that we're used to, which is we have to pay them. Right? To that worker. The second cost, which wasn't the case in a competitive market, but is the case now that we can choose different wage levels and attract different numbers of workers at different wage levels, is that we have to raise wages on everyone else in order to get an additional worker to work for us. Right? So this is going to be a cost of L, right, the number of workers I already have, times the change in wage needed to get an additional worker to work for me. This makes sense? So I should point out here, I'm not sure how explicit I was before. I should point out here that the idea is, as a firm, I can choose different levels of pay, right? Get different workers to work for me. I have to pay everyone the same amount, right? I can't look into someone's eyes and know what their reservation wage is, right? The minimum amount I need to pay that person is. I just know that in order to get 50 workers, I need to pay $11 an hour. To get 60, I need to pay $13 an hour, right? This is why we're going to say this. Okay. So this is the idea, right? This is the core intuition with monopsony models. is essentially that because firms are able to depress wages and not lose all of their workers, hiring extra workers has this additional cost of having to give everyone a raise. We can think about this mathematically by saying, whereas in a competitive market, right, the marginal cost of a worker right, in a competitive market, it was just W, right? And the reason was that the total cost is W times L, right? The derivative of WL, when you don't have any control over W with respect to L, is just W, right? In a competitive market, this was the case. In a non-competitive market, this isn't going to be true because now W depends on L, right? So we can do exactly the same thing. We can say that the total cost of labor is going to be W times L, W of L times L, right? So marginal cost of labor is going to be the change in that total cost with respect to a change in labor. This makes sense? We're asking how much does my total wage bill increase when I hire an additional worker? Now, we can figure this out just using the product rule, right? So the product rule is going to tell us I've got WL times L, derivative of this with respect to L. It's just going to be WL times derivative of L. With respect to L. Plus derivative of W with respect to L times L, right? This is just the product rule, which is, of course, dl is 1, so this is just going to be W of L plus dW dl times L, right? This is going to be my marginal cost of labor, or as I'm going to call it, my marginal expense of labor. And this is just a mathematical derivation of the logic we started out with here, right? What we're saying is the cost of hiring an extra worker is the wage we pay to that worker themselves, right? WL, the wage necessary to hire an additional worker, plus the raise we give everyone else, dWdL, times the number of workers we've already hired. This makes sense? So if we think about what this is going to look like, for a zeroth worker, right? If we don't already have any workers on staff, this is just going to be equal to the wage rate, right? Because L is 0, right? So dL times L is just equal to 0. But as we hire more and more and more workers, my marginal expense of labor is going to get larger and larger and larger relative to my wage, right? The difference between the wage and the marginal expense of labor is going to grow because of the fact that I'm giving raises to more and more and more existing workforce, right? So marginal expense of labor is going to get larger and larger and larger compared to my wage rate, right? The difference is going to get bigger and bigger and bigger. This difference is dWdL times L. Great. And what's going to be my optimal choice of labor, right? How many workers am I going to want to hire? Well, I'm going to do exactly the same thing that I did before. I'm going to hire workers up until the marginal cost of an extra worker, right, or the marginal expense of labor, is equal to the marginal revenue, right? I'm going to hire workers up until the money brought into my company by hiring an extra person is equal to the money going out of my company from hiring an extra person. So that's going to mean that rather than hiring here, I'm going to hire here, right? Where MEL equals my marginal revenue product. This makes sense? And what wage am I going to offer those workers? I'm going to offer those workers the lowest wage that they're willing to accept, which is going to be given by my inverse labor supply curve, right? I'm not going to hire them at a wage equal to marginal revenue product. I'm going to hire them at the lowest wage they're willing to accept. So this is going to be my W star, this is going to be my L star. Great. Now, there's a couple things that I want to point out about this that I think are really important, and they're going to help us think about this model as we start trying to use it. The first thing that I want to point out is that at this wage, and in particular at this number of workers L star, we are not at an economically efficient level of employment. What I mean by this is, right, if we think back to what we said about competitive labor markets, we said that wage equals marginal revenue product is this really important finding because of the fact that the wage rate, right, given by our labor supply curve, is essentially going to tell us the value of a worker's outside option, right? It's going to tell you the value of a worker's leisure time if they're choosing between working or engaging in leisure, or the value of the worker's alternative possible compensation, right? The wage that they could get at a different job, right? It tells you the amount of money that a worker is willing to take in order to work at a job, right? Meanwhile, the marginal revenue product is going to tell us the value to consumers of the product being produced, right? It's going to tell us how much consumers value the opportunity to sit in his lap and pull on his beard, or the value of the burgers that they're eating, or the value of whatever it is that a worker's producing, right? So we said that hiring every worker whose reservation wage is less than their marginal revenue product means hiring every worker whose time is more valuable to society in some sense when transformed into burgers or Santa experiences or whatever it is that they're producing, than when used to hang out with their kids or work at a different job or do whatever else they would do with their time. That is not the case here, right? We know that that's not the case here because there's this big difference here between the value of this last worker's time who's hired and the value of the stuff that they're producing, right? And there's all of these workers whose time is worth less to them when used somewhere else than the stuff that they're producing, right? Their time would be less valuable to them hanging out with their kids at home than it is when transformed into hamburgers. This makes sense? And so this is going to result in a deadweight loss, right? A loss to society of this triangle right here, right? The difference between the value of stuff that would have been produced if we hired at the economically efficient level and the value of the time that would have been used to produce that stuff. That's the first really important thing I want to point out. The second really important thing I want to point out is that in a real sense, at the wage rate that employers are choosing when they have market power, supply does not equal demand. What I mean by this is, at this wage rate W star, L star is the number of workers willing to work at the wage W star. How many workers are employers willing to hire at a wage W star? It's not going to be, right? The natural thing to think is, well, employers stopped here, right? They chose L star, so employers are willing to hire L star workers. That's not the case. The reason that they only hired L star workers is because it wasn't worth it to them to give anybody a raise to hire more than L star workers. But the number of workers they'd like to hire at this wage are all of the workers who would produce at least W star worth of stuff. This is the number of workers that are demanded by employers, right? So in a monopsony, in a labor market with market power, where employers have market power, you should see employers saying things like, it's just impossible to find good people, right? We have vacancies open, they're never getting filled. There just aren't enough trained workers in America these days, right? People aren't willing to do the kinds of jobs that are available. These sorts of things make perfect sense in a monopsony model because of the fact that employers have an incentive to set wages below the level where supply would equal demand. And as a result, employers are always looking for new workers and unable to find them. Okay, cool. So I'm going to put a little bit of meat on these bones. I'm going to do a little math with this model to help you guys understand it. Then we're going to start thinking about policy. So let's imagine that we're some firm with market power, right? We've got a particular labor supply curve, particular production function, which we're going to choose just to make this simple, easy math. Right, so let's imagine that we've got labor supply given by something like LS of W, right? The labor supply to this firm is going to be 10W. And we've got a production function given by something like Q equals F of L is going to be, let's say, 3L plus or minus L squared over 100, right? So that we've got diminishing marginal returns for labor. And what we want to know is how many workers are going to be hired by a monopsonistic firm and how much we're going to end up paying them, right? So what do we need to do in order to know this? Well, what you might remember, right, from what we just did, go back to the picture we've drawn, right, we had L and W. We said we had a labor supply, inverse labor supply, W of L like this. We had marginal revenue product like this, right? We had a marginal expense of labor like this. And we hired up until our marginal expense of labor equaled our MRP, right? So we said this was L star and this was W star, right? Hopefully it looks familiar. So this means we just need two things in order to figure out our answer to our question. One is we need our marginal revenue product. The other is we need our marginal expense of labor. Cool, right? And we're going to need our inverse labor supply, right? WL. So let's start with the MRP. We've done that before, we like it, right? Oh, and let's say that we're selling stuff at a price of $10, right? We're selling in a perfectly competitive product market. Okay, so our MRP is just going to be the price times the marginal product of labor, right? Which is going to be the price times the QDL, right? This is just going to be 10 times the derivative of this thing with respect to L. Derivative of 3 with respect to L is 3. Derivative of negative L squared over 100 with respect to L is, of course, negative 2 times L over 100, so minus 1/50th times L. Make sense? So we're going to get 30 minus 1/5 L as our marginal revenue product. Wonderful. Okay. So now that we have this, right, we've got this out of the way, let's think about the labor supply. So first of all, how do we get our inverse labor supply? Right, how do we find out what wage a firm's going to have to offer in order to hire L workers? Well, we just take our labor supply curve and solve for L. Right, so we'll say W is of course going to be L over 10. That's our inverse labor supply. Right? Lovely. How do we get our marginal expense of labor? Well, our MEL. Right, so this is step 1, this is inverse labor supply. Step 2 is we're going to find our MEL, right, which we're going to do by saying our MEL is going to equal the wage plus dW dL times L, right? Pay this worker, give everyone else a raise. So what's dW dL? Well, if W of L is L over 10, it's just going to be 1 over 10, right? The derivative of L over 10 with respect to L. Lovely. So our MEL is just going to be L over 10 plus 1/10 times L, right? Which is going to be L over 5. Lovely. Okay, so now we've got a marginal expense of labor given by L over 5. We've got a marginal revenue product of 30 minus 1/5 L. So in order to find out the number of workers, right? We're just going to set our marginal expense of labor equal to our marginal revenue product, right? So we'll get L over 5 equals 30 minus 1/5 times L, right? Combine the L, so 2/5 L equals 30. L is going to equal 5/2 times 30, which is going to be, let's see, 1/2 times 30 is 15, so 5/2 times 30 is 15 times 5 is going to be 75. Lovely. Okay, so we're going to hire 75 workers. And how much are we going to pay those workers? Well, we're going to pay them as little as we can, which we're going to get from our inverse labor supply curve, right? So the wage that we have to pay L star workers is just going to be L star over 10, right? So the wage that we pay 75 workers is going to be 75 over 10 equals 750, right? So we're going to have an L star of 75, W star of $7.50. Cool. This makes sense? Wonderful. Okay, now just so we can understand what this means, right? Understand the implications of this, I want to compare this to what would have happened if wages were equal to marginal revenue product, as they would be in a competitive market, right? So if instead we had wage equals to marginal revenue product, right, we would have had W of L, we said it was 1/10 L, marginal revenue product of L was 30 minus 1/5 times L, right? So if we had 1/10 L equal to 30 minus 1/5 L, we would have gotten 3/10 L equals 30, L equals 100, right? And therefore wage equals 100 over 10 equals 10, right? In other words, because of the fact that we're in a monopsonistic environment where firms have the power to lower wages, right, to offer artificially low wages in order to increase their profits, we're going to have workers earn a wage of $7.50 instead of earning a wage of $10, right? And we're only going to have 75 workers hired instead of 100 workers hired, right? So this economically efficient outcome would have been $10 and 100 workers, right? Instead, we're going to end up with our monopsonistic outcome of 75 workers at $7.50 an hour, right? This is our MEL. This is our WL. This is our MRP. And what this means for welfare is a couple of things. The first thing, as we talked about before, is that there's a loss to society given by this, right? $25 workers who produce more in an hour, right, more value in an hour than their time is worth to them doing something else, which is a loss to society. We also have, right, a consumer surplus that goes from including this to also including some of this, right? So we've got this area here, the difference between $10 an hour and $7.50 an hour, right, for the 75 workers hired, which is producer surplus taken by the firm and transformed into consumer surplus, right? We've got this area down here, remaining producer surplus. Right? So just like a monopoly, what a monopsony is doing is essentially creating losses for society in order to transform some of the benefits that would have accrued to the workers of the existence of this labor market into benefits to the firms, right? Benefits the firms take for themselves. And as a result, the wage that workers end up getting paid is rather than just being a function of their marginal revenue product, right, the value of stuff they're producing, it's also going to be a function of the degree to which firms are able to do this, right? Essentially how upward sloping the labor supply curve is to their employer, which is to say how much power their employer has over them, right? How available outside employment options are for the workers in a particular industry or working for a particular firm. Okay, cool. So where we're going to go next with this is we're going to use this model to think through the implications of a minimum wage.